Okay, uses of data. We have two uses of data. One is descriptive statistics, and the other one is inferential statistics. Descriptive statistics merely describe. In descriptive statistics, we collect, organize, summarize, and present data. That's like chapters 2 and 3 in your book, and little bits and pieces elsewhere. Inferential statistics goes beyond descriptive. It's one thing to describe something that's going on. It's another thing to say, because this happened over here, then this will happen over here. That's making an inference, okay? Or because this happened here, and it happened like that there and there and there, then somewhere in the middle it should be right here, okay? We'll learn about that kind of tendency when we talk about line of best fit and that. Inferential statistics. We could say, because, I don't know, we'll talk about it when we get there. Basically, inferential statistics is generalizing from samples to populations. I say, oh, because this is true about this sample, then it's also likely to be true about the population from which I took the sample. We use inferential statistics to estimate, to make hypotheses and test them, and determine relationships, like is there a correlation, and to make predictions. An important thing in inferential statistics is probability. Probability helps determine our uncertainty when we make inferences and our confidence level. Population, I used it up here. Population is the complete group of objects or subjects from which I might take a sample. Sometimes, like, I want to test something and I have a very small population, so I might do my survey or my test with all of them. Other times it's just too expensive to test them all. Let's say I want to know what percent of light bulbs are defective. Well, I don't want to break or test every light bulb until it croaks and burns out. I want to maybe test a large sample from the population, and from that I can infer that, you know, X percentage last this long, X percentage lasts this long, and then based on that sample I can decide for how many hours am I going to warranty my population, and that way I can determine a value for which, you know, if I warranty them for 1,300 hours, maybe I'll only get at most 5% of my light bulbs or laptops or whatever returned. And how do I determine the length of the warranty? So that I get no more than 5% or no more than 10% returned, and so I can be relatively confident of that. That's all inferential statistics. So stuff we'll learn about as we progress. Let me stop there.